Did four chapters. Up till now, we have studied four chapters. First chapter is Introduction of Object Oriented Modeling and Design. Second, Object Modeling Technique. Third, Events and States. And fourth, Modeling as concepts. So, up till now, we have studied a section first. Let us start a section second, the most easiest chapter, design pattern first. So in the chapter we will study what is a pattern, what makes a pattern, pattern categories, relationship between patterns, pattern description, communication patterns, in that forwarder a receiver, client a dispatcher a server, and publisher subscriber. So first we will study what is a pattern. So pattern help you build on collective experience of skilled software engineers. They capture existing well prone experience in software development and help to promote good design practice. Every pattern deals with specific recurring problem in the design or implementation of a software system. Patterns can be used to construct software architectures with specific properties. So, abstracting from specific problem solution pairs and distilling out a common factors leads a to pattern. These problem solution pairs tend to fall into families of similar problems and solution, with each family exhibiting a pattern in both the problem and solution. While doing a mega project, you should know your problem statements. There are various types of solutions. So there is a pair of problem solution which falls or divided into different or similar families of problem and solution, with each family exhibiting a pattern in both problem regarded with a particular solution. So an architect, Christopher Alexander, defines the pattern as each pattern is a three-part rule which expresses a relation between a certain context, a problem, and a solution. So the element in the world, each pattern is a relationship between a certain context, a certain system of forces which occurs repeatedly in the context, and a certain spatial configuration with which allows these forces to resolve themselves. As an element of language, a pattern is an instruction which shows how these spatial configuration or spatial configuration can be used over and over again to resolve the given system of forces wherever the context makes it relevant. The pattern is, in short, at the same time a thing which happens in the world and the rule which tells us how to create that things and when we must create it. It is both a process and thing, both a description of a thing which is alive and a description of a process which will generate that thing. So what are the for properties of patterns for software architecture? So there are total 8 properties. So first, pattern addresses a recurring design problem that arises in a specific design situation and presents a solution to it. Patterns document existing, well-proven design experience. Patterns identity and specify abstraction that above level that are above level of single class and instance or of components. Patterns provide a common vocabulary and understanding for design principles. Patterns are means of documenting software architectures. Patterns support the construction of software with defined properties. Patterns help you build complex and heterogeneous software architectures. Patterns help you to manage software complexity. So, what is the final definition of pattern, or what is the conclusion about above 8 properties? So, pattern for a software architecture describes a particular recurring design problem that arises in specific design context and presents a well-proven generic scheme for its solution. The solution scheme is specified by describing its constituent components, their responsibilities and relationships, and the ways in which they collaborate. So, what is the pattern? The three-part schema that underlies every pattern. There are the three parts, that is context, problem, and solution. What is a context? A context is a situation giving rise to a problem. What is a problem? The recurring problem arising in that context. And what is a solution? A prone solution of the problem. So, what is the context? We will see in detail. The context extends the plain problem solution dichotomy by describing the situations in which the problem occurs. Context of the problem may be fairly general. For example, developing software with a human computer interface. On the other hand, the context can tie specific pattern together. Specifying the correct context for a problem is difficult. It is practically impossible to determine all situations in which a pattern may be applied. We cannot say. For example, we are studying in C language is for loop, while loop, do while loop. The same problem can be solved within with the help of these three loops. So it is practically impossible to determine all situations in which pattern may be applied. So second concept is a problem. This is a part of pattern description schema describes the problem that arises repeatedly in the given context. It begins with a general problem specification, that is capturing its very essence. What is the concrete design issue we must solve? The general problem statement is completed by a set of forces. The term force denotes any aspect of problem that should be considered while solving it, such as a requirement the solution must fulfill, constraints you must consider, desirable properties the solution should have. The forces are the keys to solving the problem. Better they are balanced, better the solution to the problem. Then third part is a solution. The solution of a pattern shows how to solve the recurring problem or how to balance the forces associated with it. In software architecture, such a solution includes two aspects, such as every pattern specifies a certain structure, a spatial or spatial configuration of elements, and every pattern specifies runtime behavior. So every pattern specifies a certain structure, a spatial configuration of element. This structure addresses the static aspect of solution. It consists of both components and their relationships. And every pattern specifies runtime behavior. This runtime behavior addresses the dynamic aspects of the solution, like how do the participants for a better collaborate or pattern collaborate, how work is organized between them. So it have 4 points, such as the solution does not necessarily resolve all forces associated with the problem. A pattern provides a solution schema rather than a full specified artifact or a blueprint. No two implementations of a given pattern are likely to be the same. So the following diagram summarizes the whole schema, the pattern. So it have three parts such as context, problem, solution. What is the context? Context is a design situation giving rise to design a problem. What is a problem? Regarding design, set all forces repeatedly arising in the context. And what is the solution regarding that problem? So configuration balance the forces, structure with components and the relationship, and runtime behavior. This is the whole structure for the pattern. So pattern categories, there are three categories of patterns: architectural pattern, design pattern, and idioms. Each category consists of patterns having similar range of scale or abstraction. So we'll study one by one in detail. Architectural pattern. So architectural patterns are used to describe viable uh, software architectures that are built according to some overall structuring principle. So architectural pattern expresses a fundamental structural of organization schema for software systems. It provides a set of predefined subsystems, specify their responsibilities, and include rules and guidelines for the organizing the relationship between them. So figure shows this is the architectural patterns. Whenever you are doing a mini mega projects or any projects, there are three parts: model, controller, and the view. In model, encapsulate the application state, respond to the state queries, expose application functionality, and notifies views of changes. So dark line or solid line indicates method invocations. So methods are invoked from the view as well as from the controller. So and view and controller communicates with each other. So in the view, there are renders the modules, request updated from models, sends user gesture to controller, allows the controller to select view. Similarly, in the controller, defines the application behavior, maps the application to model updates, selects the view for a response, and one for each functionality. So, suppose model or module is a program, controller that is a designer of that program, view suppose the customer regarding that program. So, customer state the query to the model. If the customer does not get a required or expected result, then model should be changed or change notification done from module 2, or customer realize that there may be need of some changes, so he communicate or customer communicate to the designer, that is if you communicate to the controller, that is user gesture. As per requirement of customer, the designer change the uh, states of the modules, that is change state, and always and as well as communicate with the customer, that is view section. Again, customer state a query. Whenever customer does not get or customer does not satisfy regarding this model, then he gives the change notification to the controller, from model to customer to controller. This is the architectural patterns. So this architectural patterns, first event is passed to the controller. Event is passed to the controller, then controller changes models or views. There are number of views. Okay, then views agenda from the model. These views change to the as per requirement. So model updates views when data changes. This is the flowchart diagram of the architectural pattern of previous diagram. Then this is the communication of controller class, view class, and this is a model class. So in model there may be student, maybe this is the example of student progress card. So class controller have events load, save. View controller, view class have fields like ID, name, grade sheet, method is display. So in model, there are two fields, class student and class grade card. So student fields ID name and student history, that is ID, total marks, grade, remark, methods. This is the examples of student grade card. This is the architectural patterns. Then design patterns. Design patterns are used to describe subsystems of software architecture as well as a relationship between them, which usually consist of several smaller architectural units. What is the definition of design patterns? A design pattern provides a scheme for refining the subsystems or components of a software system or the relationship between them. It describes the commonly recurring structure of communicating components that solves a general design problem within a particular context. They are medium scale patterns. They are smaller scale than architectural patterns but tend to be independent of particular programming language or programming paradigm. For example, publisher subscriber pattern. Then third is idioms. An idiom deals with the implementation of particular design issue. So idiom is low level pattern specific to a programming language. An idiom describes how to implement particular aspects of components or the relationship between them using the features of given language. Idioms represent the lowest level patterns. They address aspects of both design and implementation. Example, counted body pattern. So pattern description, it have some properties. First property is name. So name and short summary of the pattern. Pattern also known as other names for pattern if any are known. Examples of patterns, that is the real world example demonstrating the extent of the problem and need for the pattern. Then context, the situation in which the pattern may apply. Then problem, the problem the pattern addresses, including a discussion of its associated forces. Then what is the solution regarding that problem? The fundamental solution principle underlying the pattern. Then what is the structure of that pattern? A detailed specification of the structural aspects of pattern including CRC, that is cards for each participating components, and an OOMD class diagram. Then dynamic, a typical scenario describing the runtime behavior of the pattern. Then implementation, so guidelines for implementing pattern. These are only suggestions, not immutable rule. Examples resolve, discussion for any important aspects for resolving the example that is not yet covered in the solution, structure, dynamics and implementation sections. What are the variants regarding the patterns? A brief description of variants and specialization of pattern. So what are the known uses? the examples of the use of pattern taken from existing system and what are the consequences, so benefits the pattern provide and any potential liabilities. So we'll study one by one a pattern. First is communication pattern. Most of today's software systems run on distributed system. These distributed systems needs a means for communication. So what is the problem? Many communication mechanisms to select from. The use of communication facilities is often hardwired into existing applications, leading to various problems such as difficult to change communication mechanism later, then portability, then migration of subsystems from one network node to another is only possible if the communication facility allow it. What is the solution regarding this? Loosen the coupling between components of distributed system and the mechanism it uses for communication. For example, by using encapsulation and location transparency. So we discussed the two pattern addresses regarding these topics. First is forwarder receiver design pattern. In this is a part of communication pattern and client dispatcher server pattern. So which provides location transparency. So keeping cooperating components consist is another problem in communication. We discuss one more pattern, address the issue that is publisher subscriber patterns. So first is forwarder receiver problem. In this picture we are seeing there are four machines, or this is the example. So they are in the network communicated with each other directly or indirectly in both ways. So many components in distributed system communicate in peer to peer fashion. The communication between the peers should not be dependent on a particular inter-process communication mechanism, that is IPC mechanism. The performance is always an issue and different platform provides a different IPC mechanisms. So what is the solution? To encapsulate the interprocess communication mechanism, peers implement application services. Forwarders are responsible for sending requests and more messages to remote peers using specific IPC mechanisms. So there are forward. This is in this figure. This is a peer one known as known as here, and this is peer second known as there. So in every peer, forwarders are responsible for sending requests or more messages to remote peers using specific IPC mechanisms. So receivers also are reversible for receiving IPC requests or messages sent by remote peers using specific IPC mechanisms and dispatching the appropriate method of their intended receivers. So in peer 1, see in this figure, in peer 1 there is service. So forwarder has properties marshal, deliver, send message. This message sent towards the receivers. The receivers receives unmarshal and receive message from this peer to here peer. Peer name is here. from here pair to their pair. This is another pair. The name is there. So this communicates to with his peer and provide to the service and send message to the forwarder. Then forwarder forwards the message. Marshal deliver send message to the receiver of here. So it will receive the message that is receive unmarshal and receiver message. So internet, the forwarder receiver design pattern provides transparent inter-process communication for software system with peer-to-peer interaction model. In it introduces forwarder and receiver to decouple peers from the underlying communication mechanisms. Then what is the motivation? Distributed peers collaborate to solve a particular problem. A peer may act as a client requesting services as a server providing services or both. The details of underlying IPC mechanism for sending or receiving message are hidden from peers by encapsulating all system specific functionality into separate components. Examples of such functionality are the mapping of names to physical locations, the establishment of communication channels, or the marshalling and unmarshalling of messages. Then this is the structure of peer interprocess communication from peer to receiver, receiver to forwarder, forwarder to again peer. So the FR communication, that is forward receiver communication, it consists of three kinds of components: forwarders, receivers, and peers. So peer components are responsible for application tasks. So peers may be located in different process or even on different machine. It uses a forwarder to send message to other peers and a receiver to receive message from other peers. So from peers send message towards a forwarder. There is one-to-one communication. There is one-to-one communication from forwarder to receiver. So marshal, deliver, and send message. Similarly, there is a receiving message from peer also, a receive, then marshal, receive, unmarshal, receive message, and inter-process communication message. This is structure of forwarder receiver communication. Then this continuously monitor the network events and resources and listen for incoming messages from the remote agents. Each agent may connect to any other agent to exchange information and requests, to send message to remote peer, and it invokes the method send message of its forwarder. It uses Marshall send message to convert messages that IPC understands. To receive, it invokes a receive message method of its receiver. To unmarshal, it uses unmarshal receive message. Forwarder components sends message across the peers. When a forwarder sends a message to a remote peer, it determines the physical location of recipients by using its name to address mapping. with the help of following points. Kinds of messages are command message, which instructs the recipient to perform some activities. Then information message contains data. Response message that allows the agents to acknowledge the arrival of message. It includes the functionality of sending and marshalling. Receiver components are responsible for receiving messages. It includes the functionality for receiving and unmarshalling messages. Then next point is a dynamics. So tier 1, that is dynamic message, contains data. Response message contains response data. Response message contains response data. That is your P2. It's Hello. So next point, dynamics. Peer 1 request a service from a remote peer P2. It sends a request to its forwarder 1, and specifies the name of the recipient. Forwarder 1 determines the physical location of a remote peer and marshals the message. Forwarder 1 delivers the message to the remote receiver 2. At some earlier time, peer 2 has requested to its receiver 2 to wait for an incoming. This is the concept of dynamics. Then next part is a request. Now receiver 2 receives the message arriving from the forwarder 1. Receiver 2 unmarshals the message and forwards to its peer P2. Meanwhile, P1 calls the receiver 1 to wait for a response. P2 performs the requested service and sends the result and the name of the recipient P1 to the forwarder 1. Forwarder marshals the request and delivers it. Receive 1. Receive 1 receives the response from P2, unmarshals it and delivers to P1. Then implementation. Specify name to address mapping, server or specify message protocols to be used between peers and forwarders. Class message consists of sender and data. Select communication mechanism TCP/IP socket. Implement the forwarder repository for mapping names to physical addresses, destination ID, port number, etc. So send message, destination, marshal the message. So implement the receiver blocking and non-blocking receiver message, unmarshal the message. Implement the peers of the application, partitioning into client and servers. Implement a startup configuration, initialize forwarder receiver valid name to address mapping. Then benefits and liabilities. Benefits and liabilities in that efficient interprocess communication, encapsulation of IPC facilities, no support for flexible reconfiguration of components. Then next point is known uses. So this pattern has been used on the following systems, that is a TASC, a software development toolkit for factory automation system. Support the implementation of the forwarder receiver structure within distributed application. Then it is used as a part of a reboot project, uses forwarder receiver structure to facilitate an efficient IPC in the material flow control software for flexible manufacturing. ATM implementations in IPC between statically distributed components using forwarder receiver pattern. In Smalltalk environment, Bruha, the forwarder receiver pattern is used to implement IPC. So previously description. So peer 1 sends, this is the figure, peer 1 sends a message to the forwarder 1, Marshall delivers and send the message to the receiver 2. So receiver 2 is waiting for the message from forwarder 1. So receiver, whenever receiver receives the message, unmarshal the message and receives the message. This message is sent to the peer 2 at that time. Peer 2, in case of peer 1, the receiver 1 is waiting coming message from forwarder 2. So, so forwarder 2 sends message, that is Marshall deliver send the message, and then receiver 1 receives unmarshal and receive the message. This is a structure of forwarder receiver. Then in that part is client, a dispatcher, a server. What is the goal of client server dispatcher? It introduces intermediate layer between clients and servers. The dispatcher provide location transparency, and also the dispatcher also provides or hides the details of establishment of communication. What are the applications or where it is applicable? A software system integrating a set of distributed servers with servers running locally or distributed over a network. Then components, client performs sometimes specific tasks, access operations offered by servers. So ask a dispatcher for communication channel, sends its request to the server by this channel. Then server, which provides to the client, registers itself with the dispatcher. Then dispatcher establish the communication channel, locates the server, unregister or register servers, maintains a map of server location and name. So this is a figure of components, client, server, dispatcher. So client communicate with server a request for a service. So client have parts, do task, send a request. So client also send a request connection to the dispatcher also. Dispatcher so dispatcher have fields, location map, a register service, on register service, locate server, establish channel, get channel. So it establishes the connection with the server. So send, whenever send a link from server, it accepts the link. Then server has the parts such as accept connection, run service, receive request, and it gives, this is the communication pattern, that is client server dispatcher. Then next is publisher subscriber patterns. So publisher, it has so publisher subscriber. This is the communication infrastructure. So publisher, there are number of topics to publish. So for example, we have taken only two topics, topic A and topic B. So topic A have subscriber 1 as well as subscriber 2. Similarly, topic B also subscriber 2 and subscriber 3. This is the communication infrastructure. So what is fixed spectrum? So topic A, publisher have so many topics, A, B, C, whatever. So topic A only subscribed by subscriber 1. That is, this is a fixed subscription. Then, or it is known as initial subscription. It is known as initial subscription. Then suppose there are these two topics, topic B and topic C, also subscribed by subscriber 1. This is the final subscription. So what is the goal for publisher subscriber? So to help to keep the state of the cooperation components synchronized, one publisher notifies any number of subscribers about changes to its state. Accessibility, applications in which data changes in one place but many other components depend on this data. Chatu, applicability, applications in which data changes in one place but many other components depend on this data. Number and identities of different components may change over time. For example, a GUI, that is graphical user interfaces. Then what are the components regarding publisher subscriber? So publisher maintains a registry of currently subscribed components, sends notification to subscribes when its state has changed. Subscriber can use the unsubscribe interface of the publisher, retrieve changed data from the publisher. Then push model, pusher or publisher sends all changed data when it notifies the subscriber. Rigid dynamic behavior, poor choice for complex data changes, useful when subscribers need publish information most of the time. Then what are the components? Next, pull model. Publisher only sends minimum information when sending a change notification. Subscribers are responsible for retrieving the data they need. Offers more flexibility but higher number of messages between publisher and subscriber, useful when individual subscribers are decided if and when they need a specific piece of information. Then, what are the strengths? Loosely coupled. Publishers are loosely coupled to subscribe, scalable in small installations. Then weaknesses not not so scalable in large installations. Publisher assumes that subscriber is listening. Then what are the components? So variants, gatekeeper. So publisher notifies the
सर
remote subscriber. Hmm. बोला.
बास किया था.
Hmm. Publisher notifies remote subscribers. So event channel strongly decouples publishers and subscribers. Possible to have more than one publisher. Subscribers only wish to be notified about change. Don't care which component changes occurred. Publishers are not interested in which components are subscribing. Event channel created and placed between publishers and subscribers appears as a subscriber to publisher, appears as a publisher to the subscribers. Event channel, subscriber, and publisher can be different processes, can use buffers, can be chained like pipelining. So publisher, this is the diagram. Publisher, then it have proxy publisher, then subscriber, also two parts, proxy subscriber and proxy publisher. This is event channel, then proxy subscriber, and then lastly goes to the subscriber. Then last part from this chapter, variants of the producer consumer style of cooperation. So producer supplies information, consumers accept it, strongly decoupled thanks to a buffer. Only synchronization is for buffer is underflow or overflow. Event channel patterns can simulate a publisher subscriber with more than one producer or consumer. So knowing known uses in Java Swing GUIs, this is interprocess communication or interaction protocol from publisher to subscriber 1, subscriber 2, or so many subscribers. So whenever event occurs to publisher, so notify first to itself, then occurred events sent to subscriber 1, subscriber 2, subscriber 3, and so on. This is the interaction diagram. So this is the completion of your chapter.